Hi guys, I'm Asif Ali and you're watching CGHOW video. Today I created this League of Legends based shield effect in UE5 Niagara and I'll create it from scratch. And if you haven't subscribed my YouTube channel yet, please subscribe it. If you like this video, like, share and comment. Let's start this.
CGHOW. CGHOW.
First of all, subscribe my YouTube channel and also click on bell icon so you will receive all new video notification. So the second reference is here. I will create this is static image, but I will create this. And this one I have already created. This first reference. Oh, I have this video. This one I have already created in previous video, and we have now a video of this. I didn't check, so I will create this video. I was just saying this image only. Okay. Let me download this also and open with keyframe. It shows you per frame. Oh, this is the wrong video. I have downloaded the right video. So basically we have this black ring with I think a sphere that has a Fresnel and these glowy rays, and this all thing dissolves, and there are some these petals like thing that, yeah, so this is cool. So let's create this. So first we need a ring like that. Let's make that. And this map is I created in the previous tutorial, and this girl is standing there, so you can check that. So M ring and yeah, radial, vector to radial, and just connect this one, I think. So you will have a ring. You can decrease the density 0.5, it will be softer like this, and then you have a radius 0.5, 0.2. Okay, you can also use this. And yeah, that's it, I think. And you can also use a power node here, so you can also control it from here. Okay, so I guess that's it. Dynamic parameter, this is your power, particle color, and this will be additive only. Okay. Oh, no additive, it's not be additive because it will turn to black initially. So this should be translucent. Browse this, and basically this is scaling up and just scaling down a little bit. And at the end, this is also dissolving. So let's create that also. So T noise, and then dissolve that noise. So you can make a parameter dissolve, and then this thing will multiply here, and then last thing, the tiling of this noise texture. This will be tiled. Now I'll create a Niagara effects ring, and we need that material. Delete all these for now, and I'll take the burst just one particle, and life constant maybe 1, and the size maybe 150. Turn this off. Not visible. Take a dynamic parameter. I again deleted the sprite accidentally. Okay. So in here, the power should be 2 by default, and this is 0. This is style. Let's make it 1. And you can also increase the alpha from here, and then decrease the width here. So if you dissolve it, it will dissolve like that, and you can make the tiling make 0.5, 0.6. Yeah, cool. Cool. So it will be orange and hot orange, maybe 20, maybe 100, and like this. So I'll take the color and make it float, make it curve. At 0, it will be 0. That means black. Uh, at point 1, it will be 0. At point 3, it will become 1. Okay. So the 0 part is not visible because of alpha. So you need to make the curve also here. So the values here 0.1 to 0.3. So at point 1, the alpha is 5, and point 3, the alpha is 1. I think we will make it 20 or maybe 100. Yeah. We need to shift this key little back 0.6, and this also 0.6. So can also smooth this key. Okay, and there should be a size, right? And initially it is 1. At point 2, it is 1.3, and at point 5, it is 1 again, like this. Cool. Make it local, and at the end it should fade. So in the colors, in the alpha, the last key is 0.6. One more key at 1, it will be 0. 1, and this is 0. Actually, this will dissolve, so I will not do that. In the dynamic parameter, we will dissolve it, and the value is 8. So curve, and after 0.7, at 0.7 it is 0, and at 1 it is 8. So basically it will dissolve like that. Okay. So I'll put that effects in here, the viewport. Size is very small, maybe 250. And the width is really high. So maybe I'll make this 20, maybe 10. Actually, we need to increase the density of this. I'll make a parameter for the density. So now, if I refresh, we have density. If I make it like 2, now you can see we have this thing we can use. This much is enough. Little more size, and this will be little like this. and size maybe 300. So that's it for this one. So we have this. Now we need a Fresnel sphere inside it. This one. So for this, let's make a Fresnel material. And no. And if I take the Fresnel, I don't like this one. You can see it is like a gray here, then white here. There is not a proper gradient. But if you take the Fresnel function, it is very good. It gives you that thing. Okay. So I'll use that. Then I'll take a texture. I'll take the noise and I will add these together. Okay. And to control the Fresnel, we have power here. So let's make a parameter. This is my power. And then I'll take the smooth step here. And I'll make a parameter. This is my minimum. And this is my maximum. And I will add my maximum on the minimum and that will go to the maximum. This is the process that will do something good in this effect. You will see. So if I save this and make an instance of this for now to just check, this should be 1 by default. And let me make the tiling U and tile, T for tile. Save this. So let's say you have tiling maybe 10, 20. So now you can see we can dissolve it. And if you have the gap between these two values, it will make it sharper. Like this is 0.3. If you make it 0.5, it will be sharper, or maybe 0.4, even more sharper. Cool. So I will make some gap so it will not be that sharp. It should be like this. This is how it looks. Yeah. But I think tiling is more. But this looks now very tiling, you can see. So you can do one thing, you can copy this. So let's say you are using 50 tiling here. So I have now 50 here, and then I'll copy and paste it. And this one I have 30, and then again copy paste. In this one I have 20 or maybe 15. I will add these three together, connect it here, save it. So now it is more random. Okay. So I think this much value is enough that we need. So I'll use the instance in my particle. Yeah. Yeah. So I'll make a particle color here, and then this will be lit, not two-sided, and multiply this for the opacity, and this will be direct color. Just save it. And in the particles, I'll duplicate it, Control D. This will be a Fresnel. And I don't need the sprite. So take a mesh renderer, sphere. And this instance material, I'll use that here. Okay. And we don't have any dynamic parameter here. We have just these values. And you can see that I'll reduce this to maybe 1 or maybe 5. Let me check size. So size should be maybe, yeah, 1.5 is okay. Yeah, 1.5 is okay. And this should also scale like this is scaling. So what I'll do, I'll take a scale mesh and make a float so I can copy the same curve from here and paste it here. I don't need the sprite size and this copy. Oh, why I cannot paste? Okay, because it is different type of thing. You can see the keys. At 0 it is 1.2, 1.3 and 0.51. Can just at 0 it is 1.2, 0.2, 1.3 and at zero point 0.5 back to 1. What just happened? 0.3, 1.3. Yeah. So this should also animate same. But it's making it little bigger. I'll reduce the size here. Yeah, now it's perfect. And let me see one more thing. This is also dissolving, I guess. Yeah, this is also dissolving. And this is very soft, very soft. So I'll just take the one and also one here. And in the material, I'll use this texture, copy and paste, and take a dynamic parameter to dissolve this with the power, and then multiply this thing before here after the smooth step. This is my dissolve. You can make also tiling parameter, but that's not required for now. So this is 82 by default. We set this, and if you see, you can dissolve it like this. So at 8, so like this is dissolving here, and the dissolve curve I can now copy and paste. So this is dissolving. Cool. And the last thing, not last thing, we have now this rays, and after the rays we have these petals. And when this is dissolving ring, there's a very thin line also. So what I'll do, I'll copy the ring because we don't have that thin line. I'll copy and paste it. And at the end, I will not dissolve this one. So, and I'll make that very thin like this. And this will just fade. So if you'll see overall effect, at the end we will have this thin line. Maybe we can dissolve it little later. At 0.7 it is 0. At 1 maybe 3. Yeah, that's better. Yeah, that's better. So now we need to make the rays. So M rays. To make rays, what you will do, take a texture that can be your noise, then vector to radial, and I'll use a MIP level and use it, preview it. Okay, so this is how it is, and you can use the pen, and I'll use actually both direction. I'll animate it in both direction, and then still this should be point. outward, and then multiply it with the two vector for different tiling, like 1, 1. So maybe 0.1 on X, actually here. So it will be little stressed like that, and we can make the two in this one. So we have these rays. Then we can copy these things, copy and paste. We can use the same node here. Use the different tiling, maybe this time 3 and this one maybe 0.2 and maybe difference here. Then add these together. Preview this one and I can use the power. So we will have this thing. Now I'll take the radial and I'll take 2. Okay. So one I need very sharp. So density may be 100. So it will be very sharper. Okay. And but this should be little smaller, maybe 0.5, 0.3. So when I'll subtract, because I have this softer and this one is sharper, so and smaller. So from this we will subtract the sharper one. So we will get this, and then we can add this and this together. Okay, so I'll take the saturate node here. Oh, actually we need to multiply this. I was thinking. So we got these rays. Cool. You can use a power again here, and we have one power here. I'll take the dynamic parameter. This is first power, second power, P1, P2, and that's it. Particle color, additive, unlit. So I'll save this, browse this, and in here I'll copy first ring, copy and paste. And this is my rays, and just use that material. I don't need rays to turn black, and also I don't need this for now. It should just fade after maybe 0.5. So if I preview, you can see these rays because of alpha here. So should be 1. White is very sharp. Oh, in dynamic parameter we have different values. Default to 2. So with the 1, you can the number of rays, and with 2, the height of rays. Looks cool. Okay, so this is how it looks. Size should be little smaller, like this. So if I'll see here, looks like this. And in the post, I will reset the glow. And those rays should like dissolve into this. So if this is like 1.7, if I increase like 14, you can see it dissolved. So I can use a curve at 0.7, it is like 1.5, and at 1, it is like 10, like this. Okay. And this should not be very bright. Although you can use the multiple, maybe you can use the 10 particles with random rotation here. Maybe not 10, but like 5. And this panner, I will increase the speed. Maybe this will be minus 0.6, minus 1, minus 0.8, minus 1.2. Save this. Actually, this is too fast. So time, multiply, and for the both panners, and this multiply will be a parameter time. So here in the time, if I put 0.5, I can randomize it. 0.6, 0.4. Good. Yeah, so that's it. And now the last thing is when this all dissolving, there are some petals. So we can use any texture. I have already petals, but we can use any texture. So basically, I'll make a material M that like a ashes of this. So I'll call it ash. And like you have a texture, any texture you have, like you have the aura, this one. And now you have a radial. If I preview, and if I take a texture coordinate and multiply it and take a frac and make a 4, we will have 4 radials. Then I can multiply this radial with this noise. So basically we can use the different petals, different styles, and here we can use a power also to increase or decrease things like this. Maybe 1.5 is enough. That's it. We can use this. You can use it 2 by 2 if you want, like this, or maybe 3 by 3. Total 9 frames. Yeah, 3 by 3 we can use. So now particle color. So we go here and this thing here. Save it. So I'll browse this, and in here I'll make a new fountain. This is my ash, and I'll use that material. This is 3 by 3 and random frame. So animation, use the random and 3 by 3 9 frame. Okay, and these are spawning from a sphere, maybe 20, I guess. Velocity will be like I'll use a linear uniform, maybe 20, and this is also 50 50, and gravity maybe 10, little up, and this should be a burst, maybe 20 particles, and the color is orangish, and you can randomize these things little here. So I want some alpha really hard and color maybe little 0.01. Okay, and then I'll take a rate, and this should also be random, maybe 100, 200, and minus 200, and little curl noise. And let's check how it looks. So basically the sphere is very small, 100. The size is very small. I'll turn off the mask. Maybe 60, no, 40, 30. And the direction of velocity maybe 200, 200. So these are going in this direction. And the size is too high, maybe 30 and 10. And the delay should be like 1 second. Actually, instead of burst, I will use the spawn rate and use the curve, and point 2, it will be 0, like 0.5, and this will be like 20, 50, and delay maybe 0.8, little earlier, yeah, cool. And you can also make the like size of, not this one, the size of the sprite, and I'll use the non-uniform and break this, and we can use like sign in the X and use the age here, normalize age, and you will notice if I make it little faster, like these rotating in 3D. Let's make 0.5, like it's like rotating in 3D, so I can make it 0.5 and 1 random like this. And I think size is still very high. I'll use maybe 220. Yeah. And there should be a delay of 1 second before looping again. So I'll make it 3, all emitters loop. And in this one, this will be 2.2. Now there will be time to spawn again. Okay. And the life of these ashes is too high. It should be like 1.2, 0.5. Cool. And one more thing, in the ring, in this first one, in the color, this is 0 and this is 1. I want to make this curve little down here. Like this. And the shorting, maybe 1. Yeah, cool. So that's it. I hope that's finished. This is what it is. Thanks for watching. Keep learning.